Welcome back to another video, Code 1. Today we're knocking out another video for the arrays for job interviews, array questions. So given two arrays, we're assuming no duplicates within those arrays. Is one array a rotation of another? If it is, we're going to return true or false. So they have to be the same size and the elements, same size and elements, but they're going to start at a different index location. This is going to be a big O of n. It's going to be linear. We're going to go through each array 2 times, but it's O times 2n, and again, the 2 is not going to count because constants are going to be nothing as you get infinitely large. We want to select an index position in list 1, get its value, and then we're going to find the same element in list 2 and see where it is in that index. And then from there, we're going to go index position, because again, they should be in the same size, same elements, and start index at different locations. So if I get to index position 0 of list 1 is the number 2, and number 2 is index position of 4 in list 2, then when I go to index position 5 in list 2 and 1 in list 1, it should be the same next number. So, having fun with that, let's run forward. So we're just going to call it rotation, and just like I said, we're passing one list and 2 lists. Those are going to be our arguments for the defined function. And then we're just going to do a quick edge check here. If they're not the same length, then there certainly cannot be a rotation of each other, right? So simply if the length of list 1, we do want to close that off, does not equal the length of list 2. So all we're doing here again is saying if it doesn't equal the list 2, then what do we want to do? If the lengths are different, and in a rotation the lengths have to be exactly the same, the elements have to be the same, just a different index location, well, we just simply want to return false. So we have an edge check in place. Now what we want to do is in memory, we want to create the first element of list 1. We want to store that into memory. So we're just going to simply say that we're going to call it the key, and that's going to be of 1. And how do we call the position? Just 0, because it's a list. So we can just index position 0. So we have our first variable. And the second one we're going to call key index. We're going to create a counter, and we're going to initialize it to 0. Now this is going to be what we're going to be counting as we're looking through the second list to see what that number, what that value is in that index position. So now we want to iterate through list 2, trying to find this key, starting at index 0. Because remember, when I pass the list 1, I'm already going to have in memory key the first element of list 1. So now I want to pass through list 2 and say, hey, where in your list, at what index position do you have this value, whatever this value is here? So in order to do that, we're going to do our good old for loop. So we'll say for I, and we're simply going to do the length list 2. So now we can iterate through list 2 trying to find this key. So what we want to do is we have our for loop for I in range. We're doing the range because of course we want to go for the full length of the list. And we're doing index positioning, so we want it to start at 0. Because length of the list would just count the elements. So if list 2, because we're doing 2, right? And we want to say if the index position of 2. So if the index position that I is currently at in index number 2, if it equals the key, well, what I want to do. So if list 2 has the same value that we sorted in the key, well, I want to create an increase in the key index. I want to change the key counter. I wanted to make that index, sorry. So what this is going to mean is that as we go through this, let's say I is at 2. So for 2 in range, because there will be more than 2 numbers. If list I if the element that's at position number 2, and let's say it's 5, equals the key, and let's say the first element in list 1 was 5, so let's say they equal each other, then I want the key index to now be 5. I want the key index, I'm sorry, 2, because I was going to be 2. I want the key index to be 2. So then what that would tell me is that for list 1, this element, the element at this location, the value at this location, equals the value at list 2 index location at index of whatever it was at that point, of index of 2. And yes, we're going to debug this, of course, as we go through. Now, once we have that piece in place, the next thing I'm going to want to do is I'm going to want to break out of this code. Simply because I want to force it to the next line. So once I find the index in list 2 that is equatable to the appropriate index of list 1, I then want to break out of the code. We only need to do this. We only have to do this once, and this is because we want to jump out of the loop. That's how you force a jump out of the loop. So now we're going to say if our key index equals 0, which we don't want it to, right? This would be true if we didn't find the key in list 2. So that's the only time that this would be true is, again, if we did not find the key in list 2. So we're going to return false because it means that we can't even do a rotation because it's missing one of the key values. This is missing the same value. So now we're just going to now we want to go through list 1, and we're going to iterate through the list 1, but we want to iterate through list 1, and we want to iterate through list 1 until we find that element of list 2 that matches. So again, this will make more sense as primarily as we debug it, of course. That's the best way to learn anything. So we're just going to do the range of length of list 1. Oops, went too far. And again, this will make more sense. So if list 1 index 0 equals the value of 1, and we find a 1 in list 2 at index 4, then the key index at that point is going to be 4. This up here is going to be 4. So the value of index position 0 list 1 might be 4, but the 4 in list 2 is not showing up until index position 4. So this will make more sense when we debug everything. So now what I want to do is I want to create another variable, and we're going to name it t. And what I want to do is this is just going to create we'll call it the new index for list 2. So we'll say L2 index. That's what we're going to call this one. And what we're going to take is we're going to take our key index, and we're going to add it to x. And this will be a good exercise for modulos as well. We want to take a modulo length of list 1. And this is going to become the index now for list 2. What we're doing is we're going to reassign the index for list 2. And this is where you're going to see the comparison. So if list 1 position of x, all right, so if the index position of x does not equal list 2, and this is where we're going to change its index, L2 index. So we're getting the value. We're getting the value that we've created here, and we're checking that index. So what we're saying is if the list 1, if the value at that index position does not match the value at this index position, then of course our good old-fashioned we want to rerun, Jesus Christmas. We want to return false, all right? But otherwise, we want to return true if this first line of code here is going to hold right. So why do I have we got to call in that loop, right? I wanted to break inside that loop. Okay. What I was looking at just now is why I had a red up here telling me that there was an error. And my break was on the outside of the loop, but I want this break to be inside this loop so that once I actually do satisfy this, I want to break out of that for loop and jump into the next if loop. That's all. So let's actually run this through and let's see if it works, and then we can debug it. So we're going to call our function. My goodness, I can't do these so early in the morning. We're going to call our function that we created, and we're passing 2 lists, so we're going to do brackets. So we'll put this one in order, and I guess we'll go up to 7. We'll do a comma, and we're going to do another list. Now, this next list has to have the same 7 elements, right? And the order has to be the same, but the starting point, the indexing point, will be different. So we'll do it as 7, and then we went to 1, 2, 3. So that's 1, 2, 3, 4, 5, 6, 7. So we have, this is a rotation, so this should return a true. But like I said, we're going to go and debug it, and then we'll go through that. So I'm already in array rotation. I'm going to run it through, and we get a false. And we shouldn't. It just said we should get a true, didn't I? So y is 7 on the same order. So let's go through the code. Why am I getting the wrong answer? Then they will return, so it's going to jump into this. It's going to go here. We'll create those 2 variables for I and range. So this will be starting at 0 plus equals key index 1, key index I, break. If this is a false, oh, watch this. Let me try it now. True, yep. So I was breaking out of this loop too early. My mistake. So now we get a true, so now we can actually debug this. So I'm going to hit there. Yep, array rotation. Let's load our piece into memory. All right, actually we'll keep it on the debug for now. I'm just going to bring this down a little bit. So we have our 2 pieces in memory. We have our list 1 and our list 2 and their appropriate values. And you guys don't need all of that, so we can just do this. See a little bit more. So if the length of list 1 does not equal length 2, return false. It does equal the same length, so it's going to jump down to the next aspect of code, which is we're going to create a key list 1 index 0 in memory, and that's actually going to give us the values. So if we look at list 1, the first index position value is 1. That's why it's a 1. Key index equals 0. That's just the variable key index, and we're equaling 0. Now for I in range, this is the length of list 2. So it's going to iterate through list 2. So the first, the I is going to be 0 because that's where we're starting. If list 2I, so if the index position I, so if I look at list 2, the first indexed value is going to be number 4 in index position 0. If it equals the key, right now the key equals 1, then we'll jump down and we'll break and we'll go down. Otherwise, the key index is going to equal I. So let's watch this go through. So if list 2I equals key, it did not equal key because 4 does not equal 1. Right now the key is 1, and the first element, this index position in list 2 was a 4. So we're going to go check it again. Now it's going to change up to index position 1. Well, list 2 index position 1 is a 5, and we're looking for a 1. So we're going to F8, it's going to go through it again. Now it's going to change to I equals 2. Key in still 1 because that's what we created. And index position 2 is a 6. So it's not going to be satisfied. It's going to be false. Now it's 3. Index position 3 is a 7. It's still not a 1. So we're going to F8 through that. Now it's a 4. 0, 1, 2, 3, 4. And now at index position 4 of list 2, the number 1 equals the key index of 1 in list 1. So now that they match, it should take us out of this loop. It should go to key index equals I. So it should change the key index now to 4. Good, which it did appropriately up here. Now the key index is 4. Now we can break out of this loop because we're done finding the matching sequence. If key index equals 0, so key index, it started at 0, but we've changed it. This is what it is in memory. Now it's 4. This is almost like another kind of another edge check, if you will. And we're simply it's going to skip over that because that's going to be false because it's not. Key index is now 4. Now what we're going to do is this is where we're going to go over list 1, changing the index of list 2, constantly upping it by 1 to see where it is that we're going to be within that list. And when I'm done with this, I'm going to do a little lesson on modulo because it may not make sense to some people. So for x in range length of list, so x is going to be 0 because we're starting at position 0 for the range. L2 index equals 4. So how did we get that? Well, the key index right now is 4 plus x. X is 0. 4 plus 0 is 4. 4 modulo, the length of list 1 is 7. So we can go 1, 2, 3, 4, 5, 6, 7. So 4 modulo 7 is 4. If you don't understand that, I'll do a quick video showing how that comes about in just a moment. If list 1x does not equal the list of L2 index, and right now it does not, the index position of 0 is 1, and the list 2 index position of 4, 0, 1, 2, 3, 4, is 1 and 1, so it does. So if they don't match, return false, but they do match. So now it's going to go to the next one. X is going to be 1, L index is going to have to go up to 5. So now it's checking the values at index position 1, which is 2, and list 2 index position, which is now this a 5, which is a 2. So you see how it's going element for element now. So I'm just going to go through that. That matches, so it's going to go to 2 and 6. So now we're at 3 and 3, and they actually do equal each other. So this is going to be false, so it's going to jump back into the loop. Now we're at 3 and 6. So we're at 4, 0, 1, 2, 3. So now we're at 4 for X and a position of 6. So 0, 1, 2, 3, 4, 5, 6. And we're going to be matching up we didn't even do it yet. It's not 4 and 6. It's got to be 3 and 7. Yeah, I didn't go through it yet. So it goes to an index of 0 because, again, 0 to 6 is 1 to 7, but we're doing a range. So now we're matching up index position 3 of list 1 and index position 0 of list 2. So 0, 1, 2, 3. So that's 4 and 4. So it did jump into the list. So it's going to do this until we extinguish the range of the list. And that should be it for the range, because we only get up to 6. So once we jump out of the range, then we're going to return true, because we found that these two lists, they have the same length, they are composed of the same elements, and the elements are in the same order, the only difference being the starting index position. So, and of course, if we FA through that, then in the console, it's just going to show us the true that we have. So if people didn't get this, the modulo 4, if you're sitting there saying, how the heck can 4 modulo 7 equal 4? It doesn't make sense. Some people may have even thought it might have been 3 or whatnot. Let me quickly just show why that is what it is. So I'm just going to quickly open up this program here. Let me throw on the tablet. Let me move this. So it's most people, you can actually even make this closer to 3. That's excellent. Do a nice bright green for this. So if I did 12 modulo 5, most people are going to tell me, why no 5 can go into the 12. It's the way you're supposed to be doing this is 5 times 0, 5 times 1, 5 times 2, 5 times 3, and we're going to get 0, 5, 10, 15. And you see that it fits in here. So it's going to be, we have a 2 in that spot. So then, and then how do we get to this level of here, 10? Well, it's 12 minus 10. It's going to equal 2. So that's why it's equaling 2. So with that being said, what we had 4 and 7. This is where it gets different, because 4 and 7, we're used to the bigger number being first. But now with 4 modulo 7, what we're saying is 4 goes into 7 4 is 0 times. So 4 times 0 is 0. So how many times does 4 go into 7? Well, 7 times 0 is 0. 7 times 1 equals 7. So we can't use, we have to use the 0, is my point, because 7 is already larger than 4. So if we're taking that 0, 4 minus 0 equals 4. So that's why 4 modulo that is, 4 modulo 7 is going to be 4. If we go to 5, let me do this. Yeah, I'll keep it. If we went to 5 modulo 7 and see what does that equal to, well, again, we're at 7 times 0 is 0. 7 times 1 is 7. So we're still in this middle point here. So we have to select 0. 5 minus 0 is 5. So 5 modulo 7 is going to be 5. When we get to 6, it'll be the same thing. When you get to 7, and this will make more sense to you now. Oh my goodness. So 7 modulo 7, everyone knows is going to be 0. We have no remainder left over. But why? Well, 7 times 0 is 0. 7 times 1 is 7. So we can select this. And then we're doing 7 minus 7 equals 0. And that's how we're getting that number. So modulos are always easy whenever we're, whenever it's, it's somebody who's going to be doing who's going to be doing the remainder when the top number, when your numerator is larger than your denominator. It's fairly simple to do, but it becomes, people get confused when the numerator becomes smaller than the denominator. So you have to actually understand how you're doing the math. And that's exactly why in our example, let me see if I can just do this. That's why in our example, oh, that was pretty cool. 4 modulo 7, and because this was at that point 4 plus 0, and so this was our key index value plus the x at that moment, and it was modulo the length of list 1, and this was 7 because we had 7 elements within the list 1. So 4 modulo 7 again was going to, that's why it was going to equal 4, because we were going to end up getting 4 minus 0. So I just wanted to quickly explain that because I could see people coming up with questions saying, how the heck did you get that? But that's exactly how you do it. So I hope everybody enjoyed today's video. Something I decided I'm going to do is when all is said and done, I'm going to have these code brackets printed up into almost like a little booklet that I'll throw out as like a PDF, so that you'll have a nice concise book of all the different array code pieces that we did for the job interview pieces. And I'll do the same thing for strings, and then we're going to do stacks and so forth, and queues, and we'll just kind of have it all in one concise place, so you have a nice, easy way to study. All right, guys, have a great day.